adding fractions, the main thing we have to do is to match up our denominators. They have to be the same. Now, why do they have to be the same? Well, it's because it's an idea of units. I know this isn't a unit, but if I asked you to add 5 centimetres to 8 millimetres, it would be a bit difficult unless you had them all in either centimetres or all in millimetres, the same unit. So in terms of fractions, you could argue they need to be in the same units, the same denominator. Now on this one, this is already set up and lovely to use. So what we do is we write it this way. I do a great big long line and I put 5 underneath because I know I'm dealing in fifths. And then all we have to do is we add the numerator, the top part. Do not add the denominators. That is why I've got it all under one line. So 3 plus 4, 7, and I've got 7 fifths. Now that's top heavy. Don't like top heavy. I like to tidy up in maths, make things simpler. So I'm going to make that into a mixed fraction. So if you remember, we do 5s into 7, that's 1. And if we put 5s into 7, we divide 7 by 5, we get a little remainder of 2. So that's 2 fifths, because I'm dealing in fifths. Everything is fifths. Okay, let's look at this one. Instantly there's a problem. The denominator, the unit, is not the same. So I've got to make those denominators the same. Right, how do I do that? Well, I find the LCM, the lowest common multiple, of 4 and 6. And to help me, I'm just going to write out my 4 times table and my 6 times table. So what's that? 4, 8, 12. Straight away, I recognise 12. 12 is in the 6 times table. Look, 6, 12, there it is. So I'm going to use 12ths as my unit, my denominator. So there it is, all over 12. Now we've got to look at the idea of equivalent fractions. I know that 3/4 can be written differently, but mean the same. And as long as I change the bottom and the top the same amount, it doesn't change the fraction. So what have I done to that 4? I've times it by 3. So what must I do to the top? Times it by 3 again. So that becomes 9. So let's move on to 6. What have I done to the 6? I've doubled it, times it by 2. So what do I do to the top? The same. And that's going to be 2. All I've got now is the plus sign in between. Now while I'm here, this is the same as a subtraction. So all of this work is identical if that was a subtraction. So where I'm going to do 9 plus 2, which is 11, if it was a subtraction, I'd just do 9 minus 2. The 12 stays the same. Okay? Right, let's look on this one here. I've got 3 different denominators. So what have I got to do? I've got to have the same denominator. So imagine I've done all of this work over here and I've found that the common denominator is 12. So now I can hopefully speed up a bit because I've got this all sorted. 4 times what is 12? Times 3. 1 times 3 is 3. What have I done to that 3? Times it by 4. 2 4s are 8. What have I done there? Doubled it. What do I do there? Times by 2, double it. There we go. Plus, and this time, a minus. Last stage, perhaps, we've just got to add or subtract the numerators and the denominator just stays as 12. So 8 plus 3, 11, take away 2, 9. Can I leave it like that? No, I can't. I can see something going on here. They are multiples of 3, so I'm going to cancel down. Equivalent fractions again. I'm going to divide by 3, which gives me 3, and I'm going to divide by 3, which gives me 4. And the final answer is 3/4.